The future of microchip manufacturing, the role of automation robots. Welcome to Tech Dream Gear, your ultimate destination for exploring cutting-edge technologies and innovations shaping our future. Today, we embark on an exciting journey into the world of microchip manufacturing. In this episode, we will uncover how automation robots are not just assisting, but redefining the entire landscape of semiconductor production. Grab your favorite tech gadget, settle in, and let's decode the future of microchip manufacturing together. Microchips are the unsung heroes powering our digital world. They are the foundation of modern electronics. From smartphones and computers to medical devices and autonomous vehicles. But as demand for more powerful, efficient, and compact chips skyrockets, traditional manufacturing processes face growing challenges. Enter automation robots, the game changers poised to transform this industry forever. This video delves deep into the rise of automation robots in microchip manufacturing, their impact on efficiency and precision, and the implications for global technology and economies. The evolution of microchip manufacturing. Microchip manufacturing has evolved over decades, with each phase marked by groundbreaking advancements. Early days, manual assembly and primitive machines laid the groundwork for early microelectronics. The semiconductor boom, the 1970s and 1980s saw the rise of integrated circuits and large-scale production lines. The digital revolution, the 1990s and 2000s brought advancements in photolithography and cleanroom technologies. However, the complexity of modern chips has outpaced traditional methods, necessitating a paradigm shift. The role of automation robots. Automation robots are reshaping the microchip manufacturing process across several stages. 1. Material preparation. Robots ensure raw materials, such as silicon wafers, are handled with unparalleled precision and cleanliness. Tasks include identifying impurities, precision cutting and polishing, automated delivery to fabrication units. 2. Wafer fabrication. During the intricate wafer fabrication process, automation robots perform tasks such as photolithography. Robots apply and expose photoresist layers with nanometer accuracy. Etching and deposition. Automated arms handle complex plasma and chemical etching processes. Doping. Robots ensure precise ion implantation for semiconductor properties. 3. Assembly and packaging. Once the wafers are complete, robots take over, cutting and bonding individual chips, encasing chips in protective packaging, conducting rigorous testing and quality control checks. Advantages of using automation robots. The integration of automation robots offers several key benefits. 1. Enhanced precision. Robots operate with sub-micrometer accuracy, reducing errors and increasing chip reliability. 2. Improved efficiency. Automation allows for 24/7 operations, dramatically increasing production capacity and meeting global demand. 3. Cost savings. Although initial investment is high, automation reduces long-term labor costs, material waste, and production downtimes. 4. Scalability. Robotic systems can be adapted to manufacture next-generation chips, ensuring future-proofing. 5. Environmental impact. Automation optimizes resource usage, reducing waste and energy consumption. Challenges in automation. While the benefits are significant, there are challenges to address. 1. High initial costs. Setting up fully automated manufacturing facilities requires substantial capital investment. 2. Complex integration. Merging robotic systems with existing manufacturing setups demands advanced engineering and coordination. 3. Skill gaps. The shift to automation requires a workforce skilled in robotics, AI, and advanced systems management. 4. Ethical and social implications. The rise of automation has sparked debates on job displacement and the role of human workers in the future economy. Case studies and success stories. 1. TSMC's automated facilities. Taiwan Semiconductor Manufacturing Company, TSMC, a leader in chip production, employs advanced automation robots across its fabs. The result? Unmatched production volumes and industry-leading chip quality. 2. Intel Smart Factories. Intel has integrated robotics and AI to streamline manufacturing processes, achieving remarkable efficiency and sustainability benchmarks. 3. Startups pioneering innovation. Emerging companies are leveraging robotics to produce specialized chips for AI, IoT, and other cutting-edge applications. The future of automation in microchip manufacturing. Automation robots are not just tools, they are catalysts for the next wave of technological innovation. The future holds. 1. AI-driven manufacturing. Robots equipped with advanced AI will self-optimize processes, predict maintenance needs, and improve yields. 2. Quantum chip production. As quantum computing gains traction, robots will play a critical role in the precise assembly of qubits. 3. Global accessibility. Automation will democratize chip production, allowing smaller players to compete on a global scale. A robotic revolution. The integration of automation robots in microchip manufacturing represents a pivotal moment in technological history. These innovations promise not only to meet the insatiable demand for faster and more efficient chips, but also to redefine how we think about production itself. Thank you for tuning into Tech Dream Gear. If you found this exploration of automation robots fascinating, be sure to like, subscribe, and hit the notification bell. Stay curious, and we'll see you in the next episode.